Okay, so can everyone hear me okay?
Yeah, I can hear you.
Okay, okay, great, thank you. Okay, so we're going to move on today from reflections, and we are going to look at rotations. Woohoo! In the coordinate plane. So I want to keep this in your minds, hopefully, similar to what we've been doing. Yesterday and then Thursday, we saw that there's those patterns with keep x the same, change y, flip x and y, and we can visualize those by like trying to graph it ourselves, and we should also use those results and use those rules that we found about what changes and what stays the same when we're doing our reflections. We're going to see something similar today with rotations. Before we do, I thought we could do a quick warm up and a little review with a little more reflection. So I'm going to put some reflections up on the screen, and then I'll give you a moment and ask you to tell me the line of reflection or maybe the coordinate for the reflected point. So let's try this. Try this. So I've got point A, and where is point A living? It's at 3, 5. Let's reflect this over the y-axis. If I reflect A over the y-axis, it's going to be over here somewhere, right? Where will it live? What coordinate will A prime have? Use your rule or count the squares. What will that point be after we reflect it if we reflect it over the y-axis? Go ahead and take a moment and tell me in the chat, where will A be reflected over y-axis? It's starting at 3 comma 5. What is that rule from yesterday? If it folds this way, we know it's going to be like right across horizontally, right? How far is it going to go? How high up or down is it? Okay, cool. I see one comment or idea in the chat. Top left square. Good, Anaya. Yes. I was hoping you guys would go straight to that. It's going to be somewhere in this top left quadrant. Good. I'm glad you see that. But is it going to be, for instance, up here? Too high, right? What about down in this corner? Too low? It's going to be somewhere right here. But I want to be able to know exactly where that point is going when we do a reflection over the y-axis. So here's a trick. We didn't really do this the last 2 days, but a little trick you can do if you're doing reflecting by hand is count the actual squares. Kind of like how we use the units and the squares when we're doing slope. If I'm folding point A over the y-axis line, right in the middle, how many squares or units is it away? I'm going to count them. 1, 2, 3, right? 1, 2, 3. So I'm going to go 3 away on the other side. 1, 2, 3. Stop. There's A prime. So if we're folding it over the y line or the x line, this is a pretty fast way to do the reflection if you're doing it on paper by hand. And then you could double check, okay, do these two red points look symmetrical on my y-axis? Yeah, they do. Cool. So I think I did it correctly. Let's look at the numbers. It's over 3 and up 5. Negative 3, 5, started at 3, 5. So the x number got negated. The y stayed the same. Let's try one more. Let's try number 2. Let's reflect over x-axis. I'll change my color to yellow. So if I reflect this over the x-axis, we can count how many squares down to the x-axis is it? 1, 2, 3, 4, 5. So I've got to go 5 further away from the line of reflection. So 1, 2, 3, 4, 5. And you shouldn't be moving it left or right because then it doesn't look reflected over that line any longer. Make that big since it's kind of harder to see. So here's that A prime. And you can find its location. It's at 3, negative 5. And you can compare that using the rules we found yesterday. Okay, we're going to move on now to rotations. So this is the name of the game for today is rotations. Now, I want to stress to you guys, notes. Taking notes is always very important, but for today, it's extra important. So if you haven't already, get your notes materials ready. I'm going to pull my camera up real quick so I can see all of you. I'd like you to show me your paper and pencil so I know you're ready to go and you have your materials ready to take some notes. At the end of today, I am going to ask to see your notes. So just a fair warning. I want to see that you've taken some notes of class. You'll have the new rules. We're not going to do an activity today like we did yesterday. So I want to make sure as your teacher that you have these materials written down like a cheat sheet or a note sheet that you could use later. If you are typing your notes, someone left. You will chat or email me a picture or a link to your notes. Okay. So if you're typing, you don't have paper, that's okay. But I want you to send me those notes so I see what you've done. Okay. You're not being graded on them, but I just want to make sure you're taking some notes. So I'm pulling up my camera. So just really quick, turn on your camera for me and show me, hey, here's my paper, here's my pencil. Anaya for the win, ready to go. Thank you. So I need to see Levi's, Anthony's, Brooks, Xavier's, and Tatiana's. Or tell me, hey, I'm only going to be typing them. And that way I'll know, okay, you're typing your notes and I'll expect to see those from you later. Levi, thank you. Terrific. So Brooke, Anthony, Xavier, Tatiana, please.
Got my stuff.
Thanks, Tatiana. All right, who's left? Anthony and Xavier and Brooke. You guys ready?
Yes.
Xavier, can you turn on your camera and show me, please?
Yeah.
I trust you all, but I do want to see it. Trust.
You want me to send you a picture because I'm typing it?
You're typing it? Okay. Yeah, send me a picture today. Or if you're typing in Google, you can just share it with me and I'll get an email and I can look at it later.
Oh, okay.
You know what I mean? Top right of the screen on Google Drive or Google Docs, it says share. Hit that, type in my name, Josiah, and it's going to pop up because we've shared stuff together before.
Okay.
And that's easy. You don't have to send me anything. It's already done. I will type it. Brooke, I want you to do the same thing as Xavier. I want to see your notes shared with me today, okay? Guys, I don't mean to be like a meanie or a jerk about this, but it is important to take notes. Otherwise, it's just me talking. you not getting any practice, and then I want you to have these for later. I don't want this to just you talk about it today, you have to remember it. The point of this is that we practice it together, and then you have it for later. That's why I'm pushing this, okay? Not to be annoying. All right, let's go ahead. Anthony, are you there still? All right, Anthony, if you can hear me, I need to see your note paper, or I need to know that you're typing your notes. But I'm not sure if you're there. So we're going to move on, and I'll check with you later. All right, folks, thanks for showing me that. Rotations. Now, I've given you kind of a huge hint. We're going to be seeing rules for our rotations, just like we did with our reflections. They're not the same rules, obviously, they're different. Before we do that, though, let's talk about what a rotation even is. Yeah, this will work. So just so we're clear, when we did our reflections, it's like we're folding the whole graph in half, right? Folding it like along that line of reflection. When we do a rotation, we're not folding anything. We're starting with our figure. Let's say I have a triangle shaped like this. A right triangle with a nice sharp point on the top. It's a right triangle. So if I want to rotate this around my screen or my graph, we have to have a center of rotation. That means where are you holding it still and spinning the rest around. So usually we rotate around the origin, 0, 0. All the stuff I'm going to ask you to do is rotating around the origin. We're not going to be rotating around some weird extra special points, just the middle of the screen, the origin. So if I were to hold that still at the origin and then spin the rest of my screen around it in a circular way, we're doing a rotation. It's not a very good example, but really quick, I want to show you on my camera. See if this works. And I should have made a circle to got a circle ready. Well, here's a circle. So if I hold the middle still and then spin the paper, I'm rotating it. Just like how our solar system is orbiting around the sun. Okay, not a very great example, but that's what we're doing with these rotations. I think these are a little trickier than the reflections. Reflections, we can count the squares, and it's not as intuitive with the rotations. So we usually spin counterclockwise. And just so we're clear, if you're watching a clock, clockwise goes, how do I describe that? Clockwise goes like to the right, I suppose, on the top, but counterclockwise goes the opposite way. So in math, we go the opposite way of a clock. Let me write that down. We go opposite of how a clock moves. That's what counterclockwise means, opposite of how the clock goes. So if I spin my purple triangle now, I'm going to basically be taking everything in this quadrant, like my purple triangle, and spinning it around this way. So every point that first existed originally, like my purple triangle, this is going to move somewhere over here, and this one moves somewhere over here, and this one moves somewhere over here, around that central point that's holding steady, that's staying still. Now I want to show you some specific rotations. So just like for our reflections, we had like special lines that we used, right? We looked at the x-axis, the y-axis, and then our two different lines, y equals x and y equals negative x. We're going to look at this specific rotations. Rotation of 90 degrees. And this is also a quarter turn. A quarter turn. So if I start with this triangle, I'm going to label my points as well, okay? A, B, and C. And I guess we should be thorough here. And I'm going to label, we'll use the same triangle for all of our rotations. And we'll label those points. So A is living at 3, 1. Point B is at 5, 1. And point C is at 3, 5. Okay, I do my rotation of 90 degrees. You know what? I had this set up to do it by hand. Hold on. We're going to do the same thing, but so I don't make a mistake, basically. We're just going to do this together in GeoGebra really quick. So I want you guys to be able to use GeoGebra too, to check your work, to practice. So to use it, we're going to go to geogebra.org, just hit Start Calculator. Boom. This is not some activity I made up. It's just the plain, unmessed with calculator. And I'm going to go to Tools. I'm going to make a triangle. I want to make a rigid triangle. And what did I do? 3, 1 to 5, 1. And we're going to take this up to 3. Oh, yeah, there it is, 3, 5. Okay, so that should be the same triangle I was starting with. Okay, there we go. And let's see if I can make that grid look a little cleaner so it hopefully looks less confusing. There we go. Just the whole numbers, not those little extra grid lines. And you can, when you're in GeoGebra, you can click on like the different parts, the sides, change some settings there, like the color, the thickness, dashed. You can click on the points, and then I think we can actually have it label the side, show name. Oh, well, they're showing their names. Okay, anyways, let's do a rotation of 90 degrees. So to do this in GeoGebra, we're going to find the rotate tool on the left and just click on that tool, click on our figure, and then we'll type in how many degrees we want to rotate. Rotation. There we go. They're under transformations. So we're going to rotate around a point. Notice there's also reflection about a line like we were doing yesterday. So we're going to do rotation around point. Click on that. And then we click on our figure. Oh, we're supposed to click on a point of rotation as well. So I'm going to make the origin there. Go ahead.
Do you want us to go into GeoGebra and do it?
No, I wanted you just to watch this first. Sorry for not being clear. You can if you like to, but I don't want to. I'm not going to ask for you all to show me right now. Okay. So we would click on our figure, and then you would click on this rotate point, and then it pops up and you can type in how many degrees. Do 90 counterclockwise. And there it is. So it does look like it was twisted, spun around the origin. And let me see if I can get its coordinate to pop up. A was at 3, 1, and now A prime is at -1, 3. Okay. So A prime and B prime and C prime. And then we looked at that, and A prime was -1 up 3. B prime is at -1 up 5. And then C prime is at -5 up 3. So let's just compare from A to A prime. Kind of like we were doing on our worksheet yesterday. Regular A is at 3, 1. A prime is at -1, 3. Look at those 2 points with me, and what is happening with the x and the y of each point? Notice how the 3 switched places, and the 1 switched places and then became negative.
Oh, never mind. I was gonna say they both revert.
Levi, my bad. One more time. Maybe the connection, Levi. Can you start over one more time? What'd you say?
Sorry, Josiah, could you repeat what you said? Your mic cut out for me.
My mic, yeah, and you cut out for me. So we both. I just heard you saying something good about the numbers switching, and that was it. And then you cut out.
Yeah, so
I'm sorry, Levi. I lost you again. I'm not sure if it's me or if it's the whole group, but sorry guys. Today's a little weird, I guess. My connection says it's okay. So Levi, I'm sorry. I missed you the second time as well.
it's all right.
As soon as you started talking, you just faded into to the background. I'm sorry. Can you want to try again? I can hear you good now.
Yeah.
Go for
Okay.
it.
So the numbers, they switch places
Mm-hmm.
where the points are, and then 1 becomes negative.
Yes, and specifically, which one became negative?
So A prime is the one that becomes negative, and the X point turns into the Y point,
There we go.
and the Y point replaces where the X point was.
Yes. Now, it's important to point out, did both numbers switch negative, Levi, or just one of them, like the X or the Y? Which position gets made negative?
Just one of them, and it was the original A point, the 1 there, That's the y point.
Yes.
Turns into the x point and then becomes a negative number.
Very good. Okay, and I guess I'm kind of a mess today. I'm sorry, guys. I accidentally earlier actually put this little cheat sheet up on the left side. This is what we're gonna put down for our rule, just like what Levi was describing with words or verbally. All your xy's, how they begin originally, rotation of 90 degrees occurs, and we see they swap, and whatever y was, it goes to the x position and becomes negative. Just like what Levi was saying. And really quick before we move on, let's check another one of the points from our diagram. Let's check point B. B is starting at 5, 1. So I'm going to do this below. 5, 1. And let's do it this way. Let's use the rule from the left side, and then we'll check the picture above and see if that actually makes sense. So the rule's saying switch them and make the y number negative, which is now in the x spot. So if I swap these guys, that will be 1, 5. And if I make that first number, the x position negative, the old y, that would be negative 1, 5. I look up, and that is what GeoGebra gave us and where I put it for our rotation. So for your notes, I would like to see at least that you've got like your starting figure, ABC, and you've got the rotated figure. And I do want to make sure you've written down this is a rotation of 90 degrees. And here's what the X and Y do when we do that rotation. XY becomes negative YX. I'll hold on to the screen for a second. I know it's been a minute. And then we're going to look at rotation of 180. And then we're going to look at a rotation of 270. Okay, I'm going to move on. If anyone needs more time, please tell me. It's okay. So now for the rotation of 180. So 180 degrees. You've probably heard or even said yourself in life, not even in math class, do a 180 or make a 180. And what does that even mean? Does anyone know what that means in life? Not even in a math context? Do a 180?
Turn around.
Turn around. Exactly. And the idea comes from, let's say I was an arrow coming out of the origin. And if this is me and these are my eyes, I'm looking this way. That's a weird drawing, I know. That's my head. Those are my eyes. If I turn around, I'm looking this way, right? Here's my eyes now looking leftwards. I've turned from here all the way there. So this space, this amount of turn is 180 degrees. And what this is 2 quarter turns, right? It's a half circle, just like you can kind of see a half circle that I drew here. When you do 180 degrees, you're turning a half circle turn, which is 290 degrees. It's like going up here and then one more down for a total of 180. And nicely for us, 90 degrees plus 90 is 180. So the math of it kind of fits together with the visual, I think, really well of what these different rotations mean. But let's look at the same triangle now. So I'm going to delete that and try the same thing with our triangle. And we were at 3, 1, 5, 1, and 3, 5. Okay, so I guess I was kind of piddling around too much on GeoGebra. So we'll just do this by hand. So same A, B, and C. There we go. 3, 1, 5, 1, and 3, 5. Okay. Here. You know what? I'm sorry. I don't want to mess it up any more than I probably already am. I am going to go back to GeoGebra. So I'm going to come right back to this. But I'd rather do it cleaner and have you guys see it like the way it's properly done rather than me just doing these messy drawings. I think that'll be hopefully better. Okay, so I'm going to do my rotation around a point. I'm going to go ahead and delete the first one. Rotate around point. Okay. So I click on my figure, I click on my point. And this time I want to do 180. There we go. So if we're tracking how this shape looks, the sharp point turned 90 and it was facing towards the left. It does another 90 degrees downward. We've gone a half circle's turn. And now our sharp point, this point here, C, which is not being labeled for some reason, this is facing down where before it was facing up. So the whole figure has been rotated in the opposite direction. Just like Levi said, turn around. It's turned around from where it started. So let's go back to our other graph and we'll track those points. Okay, so let's see. That's correct. Okay, so where it was once kind of pointing upwards, now that sharp point is going down. We can see how it rotated around that way. So what are these new points? What do they correspond to? So starting with the sharp points, the C prime here, that is over 3 and down 5. And B is the little point, the non-right angle. So here's our B prime. That's over 5, down 1. So that's -5, -1. And then for the A prime, left 3, down 1. Quick comparison from A to A prime. We had a 3, 1, and that became -3, -1. Okay, examine those points. Do you feel that you can make a rule or an explanation for how to change the X and Y? What stays the same? What changes? Any thoughts? Last time Levi pointed out that X and Y swapped and the Y number needs to become negative. So this time, I'm going to go ahead and just say this one. Here's our rule up on the left side. X and Y don't swap at all. They stay where they started, X, Y, but they both become negated. So all X's become -X, all Y's become -Y.
all numbers are going to be negative.
Yes, they're negated. Now, but what if you started on the where they were already negative? Like to do a 180, it should be turning around. So those negatives that it started at would become positive. So I want to emphasize that. It's not like everything just ends negative. Everything is going to be negated from how it starts.
So the numbers that were, what's it called? How do I explain this?
Let me try showing you guys with a quick demonstration on here. It's just a weighted graph that'll be faster for me. I'm going to make a new picture. Oops, I didn't mean to get rid of ABC. Whatever. Let's make a little triangle to track that's already in the negative zone, where X is negative on the left and Y is negative downward. So let's make... hang on. Guess I should have just made a triangle, but you'll see what I'm doing in a sec. Make this fancy. Hang on. Here we go, rigid polygon. So I was practicing this morning to get ready for you guys, but of course everything is weirded out now that I'm trying to do it with you. Okay, let me try it one more time. Rigid polygon. Okay, we'll go ahead and make the same like right triangle to track. Okay, there we go. So my point is, for all of you, but what Levi and I were talking about, if it starts off negative, meaning here my A, this looks like it's -6, -2. B is -2, -2. See how I purposely started with this figure where everything's a negative. If I do a rotation of 180 around the origin, it's going this way, zoop, half circle this way. My sharp point right here at C should be pointing upwards over here. So it's going to be the opposite of what I did in the first example. Let's try it. Let's do a rotation. And I got to still make my point. There we go. Okay. Rotate this guy around that point. And now we want to do a 180. So here's my rotation. Now it's up in the first quadrant where everything's positive. Why is this happening? Isn't it all supposed to turn negative? What happens when we take a negative number and we make it negative again? Remember that? Negative, negative? What is that? What happens when we have like -5?
So essentially, I think the points are the same as the original points. They're just reversed.
Yes. And by reverse, we're going from like positive to negative or negative to positive, right? Regardless how it starts, it switches to the opposite sign.
Yeah.
Yes. Is that fair, Levi?
Yeah.
Okay. I hear what you're saying. And that reverse, I like that. But I just want to be sure we're talking about like its sign, positive, negativeness. Yeah. But the numbers themselves stay the same. So like we see here, X and Y don't move. Yay. But they do become negative. So for example, if we were using numbers that started negative, and I do a rotation of 180, I made up these numbers. They're not actually on my triangle, but if I started with this point, -8, -1, rotate at 180, well, it turns into +8, +1. And that's what I wanted you guys to see, is that it doesn't make everything negative. It negates whatever's there, whatever you start with. So that includes our negative numbers. Okay, and our last one for today is the rotation of 270. This means we're doing 3/4 turns. So 90, 180, 270. So if I use the same triangle we've been using, should be this guy. Okay, I'm going to try this one again. Yeah, this should be it. Okay. There we go. First, our sharp point was pointing left when we did 90. Then it went pointing down. And now finally it's pointing to the right as we track those different rotations. So for 270, this is 3/4 of a turn or 390 degrees in a row. And if we look at those points, let's see, our A still the same as before. It's 3, 1. And the new A, the new A is actually the right angle. So the new A is at 1. Rats. I guess I should have not tried to get fancy. Sorry about that. One moment. Okay, I had the right numbers, but I had it flipped. That's correct, I think. So that way our A, yeah, that would be A prime. So A prime is at 1, -3. And then B is at 1, -5. And C prime is at 5, -3. Okay, so kind of like our 90 degree, this time we do get the swapping of X and Y. And instead of the Y number, the original Y number moving and becoming negative, it's the X number that moves and becomes negative. Now, these rules for the coordinates, they obviously look the same way. They're written the same way as what we did yesterday with reflections. I just want to emphasize again with you guys, I don't expect you to memorize these rules because they all look the same. It would be, too much for me to ask you or expect anyone, even myself, to memorize these rules. But what I do want you to do is have them written down. And if you know which type of rotation we're supposed to do, you can go right to it. So for example, if we get a problem like this is what some of the problems in Edmentum are going to be like. There's no pictures at all. It's just telling you what's happening, and we need to know which rule to use. So here's our first example. Suppose point A, and here's its location, is rotated 90 degrees about the origin. What is the location of A prime? So we can say, okay, we have our original or starting point. We're going to do a rotation of 90 degrees. Where does that put the A prime or the new rotation of A? How do we even start this? Well, we know the 90-degree rule. We wrote that down earlier. This was the first one we did. So the 90-degree rule, can anyone tell me that one? XY becomes what? First one from today, 90-degree rotation. No one wants to be the first to go, eh? I trust you guys have been writing down those XY rules, right? Okay, I see one chat. Thank you for answering. Who is this? Tatiana. Very good. Tatiana, that's correct, but I think there's one part missing. So this will be good because I don't want anyone to have it missing from the notes either. So Tatiana said XY becomes YX. For a 90 degree, one of these numbers becomes negative. It's the Y. So whatever the original Y is, it switches places and it becomes negative. So now we can just use this pattern for the point they gave us in the problem. So A is at 3, 7. So how are we going to change those numbers for our rotation? Well, they're going to swap places. And the original Y becomes negated. So positive 7 becomes negative 7. Tatiana, thank you for sharing. You're awesome. I appreciate you answering. Do we need to go back and look at all those rules again, folks? Do you have those in your notes so you can use them? The XY rules?
I have them in my notes. I was just flipping back through my book to find them.
For sure. Thanks, Levi. I figured you were doing it because you've been following along really well all day today. And Tatiana, I know you have it. Make sure you change that 1, though, to a negative Y, Tatiana. A negative YX. And I just want to make sure you guys have this. I don't have the 270 degrees. Thank you, Anaya. I'm gonna go back, folks, before we do anything different. We're gonna go back to the 270 degree. Of 270. Here's the rule in black on the left side. All XYs become Y negative X. It's kind of like the exact opposite of the 90 degree rotation. And maybe I should have built in a page where we kind of put them all together. So you know what? I think we'll do that right now. Go ahead and copy down this rotation of 270 and a little picture, a sketch, doesn't have to be perfect, of what that looks like, 3/4 turns. And then we're going to put them all together on one page. And then we'll do another example. And then I'll let you go for today. Okay, I'm going to let's put all the rules together. So here we go. Just to summarize it like we kind of did yesterday. So rotate 90 degrees. And we're assuming that means counterclockwise around the origin. The rule is all XYs become negative YX. Rotate 180 degrees. All XYs become negative X, negative Y. And then last, 270. All XYs become YX, and our X number switches and gets made negative. So it becomes Y negative X. See how now that we have them written together, maybe if you look at 90 degrees and look at 270 degrees, you see how they're the same, but the different number gets negated. Interestingly, we don't do the last one, which should be 4/4 turns, 360 degrees, a full circle. we don't need to show that one because 360 degrees rotation, it takes your original object and brings it right back to where it started. A full circle wouldn't change X and Y at all. But these other smaller amounts of quarter turns do place it in different areas. So that's why we see these rules emerging. So go ahead and add these to your notes if you haven't already. And I want to do at least one more example with you guys. And then I'll let you go for today. Suppose point B is rotated 180 about the origin. What's the location of B prime? I want to ask you to do this one for me. You guys have the rules, so you can see what happens for 180 degrees. All x, y's do what? And then we're going to apply that to what we have for point B. So please take a moment and try to rotate -1, 5, 180 degrees, and tell me what happens to its points. Where is B prime? You can go ahead and just type it in the chat when you're ready. Cool. I see one comment. Before I check, I want to wait for some more of you to try it. I know Tatiana's using her notes. I know Anaya's using her notes. I'm hoping Brooke and Xavier and Anthony are also trying these at home. So I want to hear from everybody. Go ahead and type in your XY for B prime. I'll check in just a few moments. Good. There's a second one. Good. All right. So it looks like 2 of you have answered. We're doing the 180 rotate rule for the point -1, 5. Good job. Who was that? Anaya and Tatiana. Thank you both for trying it. And I think you both got it right. Let's go over the rule again quick. The 180 rule is all xy's turn into -x, -y. So they don't move and they both get negated. Now, look at the first number for B. It's -1, right? So let's put our 1 in our 5. But if we negate both of these numbers, what's the opposite of -1? A +1. What's the opposite? What's the negation of 5? It's -5. So I've changed the sign for both of them. I see one more comment.
Okay, so I actually, about the comment that I made,
Yeah.
I had it switched around. I
It's
thought
okay.
it would go from -1 to -5, and I thought that the way that it was turning over wasn't 180. I got it mixed up.
It's okay. It's easy to mix up. That's why I want to, practice relying on our note sheet, having like a little reminder that we can look down to. But even then, it's easy to mix up. But it's all good, Levi. I'm just glad you tried. Good job to all 3 of you. So it looks like for this one, the X and Y, they stay kind of where they start, but then for both of their signs, they switch. That's the point of the negatives. It doesn't make everything negative. It's negating what's already there. So if I start with the -1, let me just write this down. I start with a -1 right here. Well, if I negate that, it turns into a +1 right here. Just be aware of that. So that's what happens when we negate a negative number. Good job, everybody. Thank you for trying that. And then I'll do this last one really quick. Suppose we have a new point, C, and it's rotated 270 about the origin. So 270, that's kind of a hard one, right? It means we're going 3/4 turns. So everything goes 3/4 of a full circle move around the origin. Now, point C, look where this lives. It's at -6, -1. It's already starting down here in negative land. So as a little sketch to know what's happening, -6, -1, somewhere like that. So if I move this 3/4 turns, 1, 2, 3. So we can visualize where this should land before we even find the exact number. It should be somewhere around here. 3/4 turns. That might be helpful to draw a sketch of the point or of the triangle or whatever the object is. And if we can feel comfortable with the main rotations, 90 is a quarter turn, 180 is 2 of them, and 270 is 3/4 turns, then we can just get an idea of where that should fall. And then we can worry about the actual location and the rule and all that, and kind of double check ourselves on it. Where does this look like it fell? Well, it looks like it's over 1 up 6. Let's see, and I started at -6, -1, based on what they told us. So let's double check our rule. The 270 rule says all xy's turn into, let me check mine. I wrote mine down too, so I'm going to check my notes. Xy's turn into y -x. That means we're not going to change the y sign. We will change the x sign. Okay, so now we try it with this point. So -6, -1. It is an easy thing to mix up and mess up. Don't be hard on yourself. Just don't give up. So the x number, that's -6. That gets negated and it moves positions. So that's going to become a +6 right there. Look at the rule above. What happens to the x? It moves position over here to the right and it gets negated. So my negative turns into a positive. Okay, now what happens with the y? Y doesn't change sign and it just moves to the other position. So it looks like the point I should land at is -1/6. So in my visualization, I was a little off. I did 1, 2, 3. I can see how I was off now, but I was still pretty close. So the visualizing, I think, is a good tool. I'm not going to stop doing it myself. Even when I'm off a little bit, you can see how if I was a little bit past, let me show you with a different color. I see why I messed up. With yellow here. So look at the original C on my little visualization. I'm going to make it like that, with that little line connecting it to the x-axis. So it's like underneath the x-axis. So when I do my quarter turn, it should be sticking out this way to the right of the x-axis. I do another. It sticks out above the x-axis like that. I do my final third quarter turn, and it should stick out right here. So it's okay. You know, I'm not perfect. It's okay if we make mistakes, but I think the visualization might be helpful. So even if we're off a little bit, so have some grace for yourself if you do make a mistake too. At any rate, the rule won't let you down if you're careful not to, go back and double check. And these rules will not fail you or me if we just trust them. They work every time. So here would be our C prime. All right, I'm talking a lot today, probably too much. I wanted to give you guys a break from doing activities, but I also think it might be better because then you're thinking more, talking more, I'm talking less. Tomorrow, I've got a plan to. I want to review some domain and range stuff with you guys. So that's what you can expect tomorrow, as well as a little small activity for you to get some hands on with rotations. Okay? Have a good day. I'll see you tomorrow.
Bye.